Hello, dear students. Today we have Proposition 6 of Book 2. Proposition 6 of Book 2. Proposition 6 of Book 2 states that if there be a line and it be cut in the middle, like bisected, and you add whatever length of line to it, then something will necessarily be the case, which is the rectangle contained by that original straight line together with the added part and the added part together with the square on the half of that original straight line will be equal to the square on the line of the half taken together with the added part. Okay? So, it's about this line, this black line, say. And if you cut, that's given. And it's given that you cut it in half in the middle and you add a part to it. So let's add a part to it. Whatever length you want. Okay, so now we have a line. We've cut it in half. And we've added a part to it. It's necessarily the case now that the rectangle contained by the whole and the added part, together with the added part, plus the square on the half of the original, is equal to the square on the half and the added part taken together. Now remember, when we have a line, we necessarily have a certain size of a square, because a square has 4 equal sides and right angles. If there's this line, you can only make one size of square with it. The square cannot be like this if you have this line. Likewise in the rectangle, because it's a right angle, when you have the two lines, you necessarily have your size of a rectangle. But these two lines in this right angle, you're not going to get this rectangle. It's not going to happen because these two lines are given. Okay? So, remember, it's about lines. That's cool. We didn't know that about this line. How do we do Book 2? We make the figures, then we show the equality of the figures, and then we reduce it back to the truth about the lines. Let's do that. Let's start by making our square. Let's make the square on the half. So now I'm going to use this colored line. This is the same line. It's just easier if we use colors. Let's make the square on the half and the added straight line taken together. Square on the half and the added straight line taken together. We make right angles, because it's going to be a square. And right angles. Okay? It's not so squarish looking, but it's good enough. Okay? Then we draw our diagonal from this point to this point. We connect our lines. Okay? Then we, from the point between the end of the line and the added line, we draw a parallel. So let's do that. Let's get some red here, because it's going to end up being a red square. So we draw from this point, given a line, a point not on it, to draw a line parallel to the other. Okay? And at this point of intersection, let's draw a line parallel to either this or this. So we'll make this orange too. From the point, right? Parallel, and then extend it. Okay, and let's keep extending this. So it'll be parallel to this. Cut it. Drop this oops, let's do it with this color. Drop this parallel to this. So given a line and a point not on it, draw a line parallel to a given line. Great. Now let's just color some things in to make it easier for you to see. This is going to be, and this will be blue. Okay, and I'll make this one, say, brown. Okay, so here we have a square, and here we have parallelograms, okay? I want to show, just to get it out of the way, I want to show that these are squares too. Now remember, because this is a square, these sides are equal. Sides of a square are equal to each other. So this triangle right here, the angles at the base are equal. Okay, so this is going to be equal to this. But here's these two parallel lines and a line falling upon them. It creates an outside angle equal to the opposite interior angle. So this is equal to this. But this is equal to this. So two things equal to the same thing are equal to each other. So the angles, here we have a triangle with the angles at the base equal. So this is isosceles triangle. That is to say this is equal to this. Okay, and this is a parallelogram, so this will be equal to this, and this will be equal to, so and it's a right angle, we made it a right angle, an opposite side, in a parallelogram, opposite angles are equal, etc. So this is a square. Likewise, in the same manner, I can prove that this is a square. We got that out of the way, good. Now let's look at this square. This and this are complements in this big parallelogram with the diameter, so with the diagonal. So we've shown in the past that the complements are equal, so this is equal to this. Now let's look at this here. These are on, remember this was the original line, so this is equal to this because it was bisected. So here you have two parallelograms on the equal bases and in the same parallels because this is parallel to this. Therefore we know that they're equal, so this is equal to this. Well, if this is equal to this and this is equal to this, two things equal to the same thing are equal to each other. So these two things are equal, okay? This equal to this. Let's add equals to equals. Let's add this chunk to this and this chunk to this. Therefore, since equals added to equals are equal, this new big chunk will be equal to this chunk. And we call that a nomen. It just kind of helps do something. A thing that's shaped like this in a parallelogram, two complements and one other parallel, is called a nomen. So this nomen, spelled like this, by the way. If you want to look it up in Google. Nomen, something like that. That's wrong spelling, but it goes with the GN. Maybe it has two M's, I don't remember. Okay, so this is equal to this. Okay? Now remember that this big old thing, not remember, but look, this big old thing is the rectangle contained by this and this. But this is equal to this because it's a square. We showed it's a square. So you can say then that this big old thing, this big old rectangle, is the rectangle contained by this and this. And this is the square on, the line of the original and the added part. And this is the added part. So this big old thing is the rectangle contained by the original line and together with the added part and the added part. Great. So this is equal to the rectangle contained by the original line and the added part and the added part. Great. Let's look at this. Let's add this to both sides so we get this big old chunk. Okay? So now we got this plus this will be equal to the rectangle contained by this and this plus this chunk, this square. But this square is the square on this, since this equals this because of the parallelogram. So now we can say that this big old chunk is equal to the rectangle contained by the original line and the added part, the original line and the added part, and the added part, plus the square on the half of the original line, okay? That will be equal to this big old chunk. But this big old chunk is the square on the half and the added line of the original line, the half of the original line, and then adding to it. Together we made a square. So now we know that the square contained by the half and the added part is equal to the rectangle contained by the whole original line together with the added part and the added part plus the square on the half. Okay? So this big chunk was proven equal to this chunk and this chunk. But this chunk and this chunk are the rectangle we showed, are the rectangle contained by the original straight line and the added part together with the added part, and the square on the half of the original line. And this big old chunk is the square on the half of the original line and the added part. Okay? Quod erat demonstrandum. We've showed that if there be a line and it be bisected and you add a line to it, that the rectangle contained by that original line together with the added part and the added part, that rectangle, plus the square on the half of that original line will be equal to the square on half of that original line together with the added part, that one line taken together, put the square on that. Okay? Repeat. If there be a line and it be bisected and a straight line be added to it, the rectangle obtained by the line and the added part together with the square on the half of the original line will be equal to the square on half of the original line together with the added part taken as a whole. Quod erat demonstrandum. Thank you so much. Bye-bye.